Okay, students, we'll go through a few of these problems from your worksheet today, or whenever you get assigned. If you notice on 1, 2, 3, and 4, they're all dealing with this circle here. Start with the entire area of the circle, and then they have you find the sector AOB, which would be this entire amount right there. It's called the sector of it. And then they have you find the triangle, area of the triangle AOB, which is then just, that part of it right here. And then finally a shaded segment. So a segment is where you have a segment on the circle that connects the segment, a chord right there, and it's between the chord and the outer part of the circle. That's called a segment. Okay, so between the chord and the circle itself, not the inside. Sector includes the entire region. That's the sector itself. Okay. All right, so I'll go ahead and do this first group here, and then you can do the others from there, because that'll cover everything basically that you'll be doing on the rest of this page, except for 21. Okay. All right, area of the circle, you should know, is pi r squared. So what is r? 7. So it's 49 pi, whatever the units are, squared. Notice that first off it says leave in terms of pi. That means the exact answer. That means you don't put pi in a calculator. You leave pi in the answer whenever it says that. Okay, so 49 pi right there. Square units. Now the sector, okay, again, that is a fraction of the whole area, 6 degrees. Well, 6 degrees out of how many degrees in a whole circle? 360 of the area. We just found the area, 49 pi. Okay, so we only want 1/6 of it, because that cancels out and that reduces down to 1/6. So now that gives me 49 pi over 6, or 1/6 of the entire thing. So that's the area of the sector. Now, area of the triangle. Okay, now remember these are called radii. So all radii are congruent. So that means first thing I should think when I see an isosceles triangle is base angles are congruent. Since I already have 60 out of the 180, I have 120 left, divided by 2. Since they're both equal, I'm down to 6 degrees. So this now is an equilateral triangle. All angles are 60 degrees. Okay. And I draw myself an altitude, 9 degrees. So we know area of a triangle equals 1/2 base times the height. Okay, so we have 1/2 the base. Okay, it's an equilateral triangle, so we already know the base is 7, because if it's equiangular, as 66 is also equilateral, and so since that's 7, all sides are 7. So the base therefore is 7. So the question is, what's the height? Remember, that's 6 degrees. That means this bisected it, so that's 30 degrees right there. So if I was to redraw that, I'd have a 30, 60, 90. Okay, and that's half of it, 3.5, so it's just 3.5 root 3. Because we know the 6-degree side is root 3 times longer. So 3.5 root 3. Okay, so half of 7 is 3.5, and then times 3.5 root 3 would be 3.5 squared, and that's going to give me 12.25 root 3. Okay, so that's the area of the triangle. That's this one, number 2. So the shaded region would be the sector minus the area of the triangle. So for that answer, let's see, I'll put it over here. Change the color. So we have the area of the sector, area of sector minus area of triangle So the area of the sector was 49 pi over 6 minus the area of the triangle, 12.25 root 3. And this is area, it would be square units. Okay. So that's what you are ultimately doing. I've shown you all 4 parts right there. So if you end up getting so 5, 6, 7, 8, it's the exact same thing, just different numbers and a different, not 30, 60, 90, but a 45, 45, 90. Okay, special right triangle there. Okay, and then here you're finding just areas of sectors, for example. Then you get back down to the segments again. Okay, so you find the area of the sector minus the area of that triangle. Okay. It's easy when it's a right triangle like that, because you have the base and the height right there. All right, let's go to the back side here. Oops, skip the page. Okay. Find the area of the sector RST in circle S using the given information. Leave your answer in terms of pi. So we're doing the sector. Okay, remember sector would be that entire piece right there would be the sector. The piece between the segment and the circle is called the segment. So that shaded region is called the segment. Okay, that's the difference between sector and segment. Okay, so we're doing sectors here. So we're not having to subtract anything off. We're doing the entire sector. So it's just a fraction of the area of the circle is all it is. So that would be x over 360 times pi r squared for all of these, 22 to 25. So it tells me r is 3, so I can fill that in. And the measure of arc RT is 30 degrees, so that goes there. So 30 over 360 is 1/12. Pi and 3 squared is 9. Of course, 9/12 reduces to 3/4 pi. And then square inches, since I'm doing area. Okay, so I just do that same thing for those ones there. And then 26, 27, 28, get back to practicing the whole thing. Notice here, we would, if that's 120 degrees right there, then the rest is 240. You'd have 240 over 360. Find that whole entire area itself. Then I find the area of that triangle right there, because it's isosceles. So it makes it 60 and 60 there and 30 and 30 here. So I'm going to 30, 60, 90. Find the area of that triangle and then just add it to the area of this sector. Okay, so I'm just telling you what to do there. You can do your calculations. Okay, find the area of the shaded segment. Okay, running actually the nearest tenth. Okay. So we would know this is 6 degrees right there, which put this down here, 30, right? Inscribed angle, for example. Okay, and then that is split in half. So each side of that is 15 on each side. Okay, so if that's 15, then this has to be 15, because remember we have an isosceles triangle because both of these are radii. Okay, so that means this has to be 15 degrees. So that's 30 from 180 degrees makes this 150 degrees right there. Okay, so you got to use multiple steps on these ones here. So for that one, I could do area of the sector minus the area of the triangle right there, and that would give me the shaded region. Okay, so here we have a regular 1, 2, 3, 4, 5, right? Regular pentagon. It tells me it's regular because, again, I have all these are equal, so 360 divided by 5. Okay, I'll be able to do that. And at 72 degrees, then for each one of these, okay, no, so it's 72 degrees, each one is 72. Don't forget, those are equal, or isosceles triangles, so base angles are equal. Okay, well, ultimately, what I'm doing here, I'm finding the area of that triangle, so I can blow that triangle up if I wanted to. 72 degrees, isosceles, so it's going to be at 36 degrees on each. Okay. I have the or the diameter is 10, so that means the radii is 5. Okay, since they gave me right here the diameter is 10, radii is half of that, 5. Each of these is radii right here. Okay, so all these are 5s. Okay, and I got 36 degrees, which makes this one at 54 degrees for a total of 90 complementary angles. Okay, so I'm going to use SOHCAHTOA to find the area of this triangle right here. Remember, it's 1/2 base times the height. Okay, I'm just giving you hints on what you're doing. I'm not going to do it for you. See if you can do it. I'm just telling you what you need to do. So you find the area of that triangle, okay, and then I find the area of the sector and subtract off area of sector minus area of the triangle, and that'll give me the area of that segment right there. But you're going to have to use SOHCAHTOA in this problem. Okay. And you might have to do it to find both this length right here. I can find this segment and double it, and then also find that segment for the height, 1/2 of the base times the height. Okay, so that gives you hints on that one. And that would also go along with this right here. Don't forget, since this 8 here is in the middle, that would be for the diameter. So 4 millimeters for the radius. Let's see. Okay. These are good, challenging questions 32 and 33. So 32 is a tougher one. Draw a circle and a sector. So I have a sector here. So the area of the sector is 3/10 the area of the circle. Okay. So if I called this, if I made this say 4, then the area of the circle will be 4 pi r squared, right? Pi r squared, so 16 pi. Now I want it to be 3/10, so how about making something that cancels with 3/10 nicely? Okay. So what if I made this 10? That's pi 10 squared, 100 pi is the area. And the sector would have to then be 3/10 of that. So that'd have to be 30 pi, 3/10. So this has to be 30 pi right here. Okay. So we know the area sector is whatever this degrees is right here. Call it x over 360 times pi r squared. Well, we already know what the pi r squared is, 100 pi. Okay, so 100 pi, and then it has to come out to be 30 pi, the area of that sector, 30 pi. Okay, so now you need to solve for x, and that'll be the measure of the arc. Where you said the area of the sector, 30 pi, and the area of the sector, area of the circle, 100 pi. So we already made it like that, so it'll be 3/10. So now you're really finding what x is right here, solving this equation for x. Okay, and that'll be the measure of the arc, and you already know the area of the sector. We already said it at 30 pi, so it'll be 3/10. Okay, so now you're just having to find the x there. All right, so go ahead and finish that off. And that'll do it, 15 minutes, 15